It's going to be very simple. We're going to talk about what happened in 8.10, what is going to be released by Monday in 8.11, and then Maxime is going to talk about 8.12. So, 8.10 was released over the summer, just after the summer, I think. Has a lot of new features, including proof irrelevant propositions. So there is a new sort S-prop, which has definitionally proof irrelevant propositions. So two proofs of a proposition in S-prop are always convertible. That's been done by Gaëtan Gilbert. We have integrated a primitive notion of integers inside Coq's terms. So you can really compute with these fixed size integers, and they're represented compactly. That has been done by Maxime Denez, Benjamin Grégoire, Vincent Laporte, and Laurent Théry. And we have also an improved system for numeral notations and decimals, and many smaller improvements. So more complete termination checking algorithm that does better unfoldings while checking termination. A new algorithm that at the base of LIA, NIA, LRA, NRA by Frédéric Besson. New intro patterns in SSReflect, and a new SSReflect tactic under that allows you to do rewriting with arbitrary relation under binders. There's been a contribution to allow to derive automatically schemes for mutual inductives in type instead of just in prop. And there's been a GTK3 port of Coq ID because GTK2 has been deprecated. So now if you run Coq ID, you're using GTK3. And support for backtraces in LTAC. And this release was managed by Vincent Laporte. And Pierre-Marie is going to talk about 8.11.
The almost released 8.11. So I happen to be the release manager with Mathieu here. It was planned to be released somewhere around the 1st of January, and it is still not released, although it's probably going to be available on Monday, if the INRIA IT sign the packages properly. So what do we have in 8.11? So the major introduction of LTAC2. Yes, you should all be should have been waiting for that a long time, which is probably going to replace on a large time scale the LTAC1 implementation that hopefully is going to be phased out. Another major extension to the kernel is the introduction of primitive floating point numbers, so that you can actually compute with them very efficiently, and they are part of the trusted code base. We already found like 2 soundness bugs, I think, in the meantime. Hope for more. What else? Yes, so a flag to allow for local checking of the termination for fixed points and positivity of inductive types that lets you write non-terminating functions, so like very similar to the unsafe flag found in Agda. Bug fix by Maxime on export and import for libraries that is likely to break everything out there. Although the fixes are pretty easy and systematic, it's kind of a pain in the neck to fix, because that's a lot of you have to take a bit of time to do that. New feature of compiled interfaces, so the VOS system that allows to develop incrementally your proofs without recompiling everything, so that you can really delay the recompilation of the dependencies and work locally inside a file. So that's great for efficient development. Bidirectionality hints. There is only one N in bidirectional, I think. Which are better behaved type inference algorithm in the typer, so that it makes dependent programming easier, because it's virtually what you would expect. The historical implementation does it the wrong way, so it's not very useful, and it's attached to constants, and you can give like you can say that some parameters are using the old algorithm, and the remaining ones are not, so that it's an opt-in feature that will hopefully also be turned into an opt-out feature at some point. Stricter syntax for disjunctive patterns, so not really like a minor change, but that is slightly that has a potential for backward incompatibility. Generalization of under-over for rewriting, and yes, major improvement of the LIA tactic that is planned to replace the Omega tactic in the next version, but probably he's talking about the 8.12. Yeah. Oh yes, there's still one slide. You didn't show me that one. 2,000 commits. Really? That's a huge number. Okay, 300 PRs. That's a lot. More than 75 issues. A lot of contributors, 61, and a lot of pain trying to get the binary packages ready for Monday because that's still not available yet. Also, soundness bug found 2 days before the release. That was great. I thank the people that find the soundness bugs before the release. Thank them. Yes, we had that was more or less the plan. The freeze occurred in November. We had a beta by the beginning of December with a slight delay, only 1 week. A bit of suffering for the release in January, and because we're sticking to the 6-month schedule, then we're going to freeze on May for the 8.12. And hopefully the release will happen somewhere before the summer. Hopefully. Yeah, that's for you.
So I can say a few words about the features that we're expecting to land in 8.12. So the release managers of 8.12 will be Emilio and Theo, but they are not here, so I'm speaking partly in their name. This is just a non-exhaustive list of features based on what people are declaring to be working on actively. So it's not nothing guaranteed yet. But some of this has already been done and integrated. So for example, there is an important improvement in type class search. Sometimes the existing type class, the way type class resolution was scheduling its exploration wasn't taking into account modes, leading to just missing some solutions in the end. So this is not integrated but already implemented by Mathieu. There is a patch, a nice patch on extraction by Xavier Leroy, improving the extraction of strings and making even more readable, like the extraction of literals and things like that. So that's already integrated. I'm working with Enrico on a better support for UIs in general, and especially LSP-based UIs. So, for example, VS Coq. So we're trying to add more first-class support on the Coq side for the kind of feedback that these UIs expect from the system. Emilio is working on using Dune not only to build Coq, but also to build Coq user projects. So that's, I mean, a lot of work has already been done, but we're also waiting for some improvements to land on the Dune side for the work to be complete. So as Pierre-Marie said, we are also planning to deprecate Omega in favor of LIA. So we hope to finally have just one tactic for linear arithmetic. We used to have 3. It was R Omega, and LIA. Michael Söktrop is working on what he calls the Coq platform. So the idea is to put in place an infrastructure to ship a set of coherent and tested packages, user packages, that are recognized as important in the Coq ecosystem, and especially to have them tested and a package for various major operating systems that you may be using. So that's great, but it hasn't really started yet. Carl Pamskog is working on some projects around incremental checking of Coq projects in a context where you have continuous integration running on your Coq code. And I'm working with Benjamin Grégoire on adding persistent arrays to the Coq language. So this can be seen as the next step after integers and floating point numbers. And there are many other things in the pipes, but that's already that already gives an idea. So now as usual in CoqPL, we would like to end with a more interactive session. So basically, So basically, we're ready to take any questions. So it can be questions on the features we mentioned or any other things. It can also be some kind of feedback on problems you're experiencing and you hope to see resolved, or even features that you recently tried and liked, things like that.
Anyone dares asking first?
When will Metacoq be updated to the newer versions?
Good question.
In the coming weeks, it's not a huge problem to update Metacoq in the sense of, well, thanks to the compatibility of Coq, the .v developments are not very hard to maintain. And we can just ignore the new features as a first step and then try to add them to the term language, to the typing derivation, formalization, and so on and so forth.
So you briefly mentioned that function might be deprecated because of equations. Is this happening?
So there is still a bit of work to be done because function takes syntax in like Coq's usual syntax of a fixed point and match, and you have to lift that to the splitting tree structure that's used internally by equations. It should not be too hard, but I just need to find time or a student to work on that. Apart from this, the feature set is the superset of the feature set of equations from the one of function. So it should be easy in that respect.
Can you speak a little bit about the arrays that are going to be added into Coq? In particular, like what do they look like? Are they dependently typed by like the bounds? Yeah, I'm wondering what the implementation is like.
So they look like imperative arrays internally, but not externally. Okay, so they expose a functional interface. They have get and set, and it looks like you're copying the array each time you update it. But internally, it uses just mutation on an array, just keeping track also of the history of mutation, so that you can do something sensible when the algorithm asks for the previous version of the array. Okay, so you can tweak this to optimize your precise algorithm. It's not dependently typed. It has essentially an array value carries a default value in the set of elements. So if you access out of the bound, then you just get the default value. So essentially, like, you don't pay. I mean, it's very lightweight on the programming side, and then in the proofs, you need to do a bit more work, like to prove that you're actually in bound. But
So are they implemented using Jean-Christophe Villetre's persistent arrays package?
yes, it's exactly the same. Well, it's a homemade implementation, but it's exactly the same idea.
You didn't mention VS Coq, but you were using it in the talk. What's the status of Coq? Oh, sorry, VS Code. Is VS Code functional now?
So I've been working a lot on VS Code in the past weeks. What I did is I took the development by CJ Bell was already fairly functional, but it was targeting Coq 8.6, and then after that, I think CJ had to do some other things. So what I did is I refreshed the implementation. I added support for recent Coq versions. I published a new release on the marketplace, and I did all this inside the Coq community. Maybe I shouldn't have. I did this under the flag of the Coq community organization. So I'm just like one of the main maintainers, but I get a lot of extra support. And so the way I see it, it's probably it's fairly stable. It gives you the same, so it's the same interaction model as Coq IDE. It has asynchronous proofs. It inherits some of the bugs of Coq IDE because of that. So I mentioned the work on the document manager. So the idea is to precisely improve on this. So VS Code today does a lot more than a normal VS Code extension, because it tries to adapt the interaction model of this protocol that was meant for Coq IDE to the VS Code world, but this cannot really be done in a completely sound way. So the idea is to remove this part of VS Code and then replace it by Coq side support. But that's more long-term work, so it will probably take a year or so, I would imagine.
I have somehow related question for all of us who attach to the proof general. Is it still considered part of the official part of the Coq ecosystem? And I seen there was work on the parallel proofs and stuff, and it's kind of stalled. I think. It seems. I
Yeah.
don't know.
So I discussed a bit various points with the proof general developers, and my feeling that branch that it existed was developed, but probably will never really make it in the main branch of proof general for various reasons. So I mean, we consider it part of the ecosystem. Now the maintenance status is not so clear to me, to be honest. So talking to the PG developers, they tend to be ready to do any kind of minor adaptations to evolutions of Coq, but like redesigning the whole thing to adjust new interaction models, new protocols, that doesn't seem to be on their agenda. And if we were to, I mean, the thing that would prevent some of us from doing it is concretely, I mean, the implementation language we're not very familiar with, and even just a piece of, this particular piece of software is a fairly complex one. So, yeah, I can't say much more.
Yeah, we can even say that Clément, who is one of the main people behind Proof General, actually agrees that the best plan for the future is to support VS Code. I mean VS Code instead of Emacs for that kind of work. So we're taking his word as well for this.
Yeah, maybe one thing that can be added is that there are modes for LSP in Emacs. Okay, so it seems that the probably proof general will be hard to redo starting from the current implementation, but it doesn't mean that Emacs support will have to be dropped. There could be another way to have nice support for Emacs. That's a separate question.
So when I upgraded to Coq 8.10, it started yelling at me in all of my files that I was implicitly declaring scopes. And then I changed it, and people started yelling at me that I broke things for all previous versions of Coq. Is there a way to make both versions sort of happy?
You introduce this.
Well, no, Mathieu and Maxime are discussing the specific feature. But in fact, I think this is a perfectly normal way of evolving. At some point, we think that something should go. We deprecate it, so you receive messages to warn you that there will be a problem. But at the time we do deprecate it, of course, if you do the changes, sometimes the changes you have to do to adapt, they may be incompatible with previous versions of Coq. I don't know any better solution than that, except that you might want to accept being yelled at for a few versions if you want to maintain a sliding window of several versions of Coq compatible.
So in the case of Iris, how we do this is we just disable these errors. So we support several versions, and then only whenever we stop supporting the version that does not support, whenever we stop supporting the Coq version that does not have this create new scope, then we'll disable the flag again, and then we add them everywhere.
Yeah, these are configurable warnings. Maybe that was.
Yeah, so that's actually something that I quite like, that all of these warnings are configurable.
So you can disable that particular warning.
Coq could also adopt a policy of not deprecating features that where no replacement exists in the immediate prior version or something like that, right? That's, I mean, seeing from other languages that I use, at least that's not the normal thing to do. Normally you add a new thing and then you wait a bit and then you deprecate the old thing.
Oh, so you mean we should have, for one cycle, added the declare scope command?
Yes.
And then next cycle, we deprecate the absence of that?
Yeah, I mean, do that for n cycles. Currently n is 0. Maybe bigger n would work.
Another option that you can also do is to add something like -w all. Then if you are using, if you're at the 0th cycle, then it will report. But then basically you have to opt in for these errors. But then only after one version, you have to opt out. Does that make sense? Sorry? I don't understand your proposal. Well, so that you can, so now we have to explicitly disable these warnings immediately whenever the feature has been deprecated. But you could first just not give warnings, and only after one version start to give warnings. That is what you propose, right? But then for the current version, you could let users opt in for these warnings. Yeah, that's what I mean. So Ralph said Rust has dash warn for stuff that's deprecated in the future. So you could add that to Coq as well. And then pedantic people that only care about master, they can.
But then you have to know the future, right?
All right.
Are you planning these deprecations? I mean, in this case, you knew. I mean, yes, when you don't know the future, you can't do it. But for this scope thing, that would have been easily doable.
No, it was a joke, but yeah, in general, we could add some metadata on those warnings to have more fine-grained flags.
Can you say more about the practical plan for moving from LTAC to LTAC 2? What, from a kind of end user's point of view, that process looks like?
Thank you.
That is a very interesting question. Thank you. Well, so there is quite a big compatibility backward, like going from LTAC 1 to LTAC 2 for simple scripts is rather straightforward. You can do that with like mostly set to replace the few places that were broken. And furthermore, because we have types, the compiler actually helps you on that topic, like it's going to spit errors and not silently fail. For more complex LTAC machinery, there is a FFI to actually call LTAC 1 from LTAC 2 and vice versa, so that you can make things interact. Depending on the complexity of this interaction, for instance, if you need to pass values from one side to the other, then you might need to understand the runtime system of LTAC 1, which I don't recommend trying to do. But for reasonable scripts that are mostly like not high order functions or anything, just like basic tactics, it's you can make the two live somehow in harmony. And then eventually, I mean, this is a personal position, but eventually I think and I hope we will be able to really phase out LTAC 1s by measuring the quantity of development in the wild. And we can do that in several steps, like for instance, turning LTAC 1 into an external plugin that is not shipped with Coq and that is part of a legacy ecosystem that would be maintained. Yeah, mostly, and yeah, you just try it. So LTAC 2, just one thing about LTAC 2. So the inclusion of LTAC 2 in the 8.11 release was mostly motivated by a need for users. So it's still evolving. So the language by itself is mostly design and everything, but the APIs are minimal and are subject to change and evolution. So I encourage any people wanting to play with that to make a lot of reports so that we can extend and start designing APIs that are useful in practice.
So you said that there is essentially a set script that can translate LTAC 1 into LTAC 2. Where is that set script?
That one is pretty easy. Like we turn semicolon bracket into.
Well, I don't know. I don't care how it looks like, but where can we download the script?
It's a one line. Okay, well, I don't know. It merely exists.
So do you have follow-up, Rolf?
Yeah.
Yeah, just one quick thing. So the key thing is, if you can, so please try LTAC 2 and give feedback. So at this point, the main motivation for the integration in this release was to have easier feedback from users.
So I recently gave a course in Coq, as I think quite a few people, and it's entirely unproblematic. So I think that's a lot of progress. So thank you for that. I also have a number of projects in the Coq community, and I'd like everyone to encourage to use this, because it really makes things a lot easier, and you get a lot of improvements, so things don't break. Then maybe some other questions. The discussion on lean versus Coq. I think one of the things that came. This was a nice flame word to start the year off with, but I think there's a very interesting discussion going on with the table type classes and the lack of canonical structures in lean. They only use them for big operators. Do you have any ideas on whether this is also relevant for Coq?
So I didn't read the paper in detail. I suppose I used some kind of caching. We tried to do that with Vadim here last year, and we found that we would need to to add a lot of restrictions to the way you could declare type class instances and which kind of classes it would work with if we had a general caching mechanism. So I suppose for some restriction of the system that corresponds to what Lean is doing, we could also do that. Yeah.
But the understanding is that the type class system of Coq is still more powerful than that of Lean?
Yes, it's basically just the hint system, right? That is reused for type class inference, so you can do arbitrary things to solve and to build instances. Yeah.
And the claim of Lean is that this is not useful and not necessary.
I don't know.
Well, I mean that seems to be the case.
Okay.
Yeah.
Yeah.
But they could be
probably
wrong.
yeah. If you want to build hierarchies of structures, you want a restricted kind of grammar for your type classes and instances, so that you know how inference is going to work and optimize it. Yes.
As we've seen this morning, there are people using the type class system to do other things, so we need to account for this use as well.
Thank you. The follow-up or different question, follow-up question. What's the status of the standard lib 2?
So basically, it doesn't exist yet. That's the best way to describe it. But there was some preliminary work done. So we basically have a modern prelude. So like all the basic data types that are loaded when you just launch Coq without any specific instruction. And so already this. So by modern, I mean taking advantage of reasonably recent features of the system, like primitive projections, and LTAC2 and other ones. Already this was in universe polymorphism. Already this was enough to uncover many problems when using these features. And another thing we did is a fairly large-scale experiment on comparing type classes versus canonical structures. So this was done by Vincent Laporte. Precisely, we were trying to get a more precise idea of the trade-offs. So this is related to the
previous point. Yeah.
And our conclusion was that at least with what type classes mean in the Coq world, if you want something to represent the usual algebraic structures and in libraries, you will pay some fundamental cost if you're using type classes. That's our understanding of the problem. So we are this experiment is encouraging us to go towards improving the implementation and ease of use of canonical structures rather than just removing them as is sometimes suggested.
Yeah, I think that's very interesting that sort of the Lean has the sort of opposite experience.
Yeah, but we may end up having the same thing under two names and claiming that we reached opposite conclusions. So I mean, we have to be a bit careful about the object we're talking about. That's my guess.
So one quick follow-up on the type classes thing. So I am using an iris for various parts, more than just normal instances, but that's mostly for workarounds.
Yes, Rob.
So coming back to LTAC2, if I recall correctly, last time I asked about FFI, that you could pass values around and even just first order values. The hacks required for that were pretty awful and actually ended up changing the proof mode. At least that were like they involved evars and stuff. So that was not very pretty. I don't know if that changed since then. But the obvious thing you want to do is that somebody refuses to add a function that converts strings to idents in LTAC1, so we might want to FFI that. And
yeah, but so there is such a thing. There are functions doing that in LTAC, in the LTAC to FFI. The FFI, nonetheless, is voluntarily reduced to a minimal amount because exposing all the horrors of LTAC1 is not recommended. Like It's mostly to like there is an intended use case for the things, and re-implementing what you're mentioning, like converting strings to whatever, is something that should be done at the language level. You can use the LTAC2 features, not not trying to go back and forth with LTAC1.
Well, but we have a large body of existing LTAC1 stuff. I mean,
Yeah, but okay, I'm not saying that okay, I'm not saying that your use case falls in the typical. I mean, Iris is not typical LTAC development.
So what should we do for Iris?
Refuse to comment.
Is there any development happening around coercions? Because I mean, there have been some questions on Coq Club, for instance, about coercions that I don't think got responses. I have a Stack Overflow question that's kind of waiting. There's been a lot of stuff that I've been expecting coercions to be doing that it doesn't seem to. And also there's this, I don't know if this is an issue, but I was just wondering if you could comment on one of these Coq Club back and forths. I was mentioned a few coercions that Coq will accept, but it will note that it doesn't obey the uniform inheritance condition, and then it will just treat it as if you never defined a coercion. And I'm wondering if that's intentional, if it's useful, if there's anything you can say about that.
Yes. So there was indeed some recent work on coercions. For example, Katsuhiko Sakaguchi improved the redundancy check for coercion along similar paths, like not reporting ambiguity when they were actually convertible and things like that, and improving some other error messages. I've been doing also some work on coercions related to the bidirectionality hints, and more generally, the implementation of coercions in Coq today would really need to be more or less redone, I think, with to take advantage of improvements having happened in other subcomponents of the elaboration engine. And so I'm not sure I saw all the questions on Coq Club, so maybe I should have a look. The uniform inheritance conditions probably should be in any frequently asked question compilation on Coq. So my view on this condition is that just the implementation is doing something very weak when it needs to insert, when it detects that it needs to insert a coercion, it has to infer some values for the parameters. And there, instead of calling the normal elaboration, the other part of the elaboration mechanism is just trying to do something ad hoc locally. And anything that doesn't, for which this heuristic is not correct, is said to not satisfy the uniform inheritance condition. So it's something that was probably cooked after the fact. That's my understanding. So I don't think this condition has any fundamental reason to be. That's the key point. If we were plugging the coercion insertion to the right place, then we should just get rid of all these things.
Yeah, I was going to add that it would help if the documentation around the uniform inheritance conversion is really hard to follow, but I guess if it doesn't make sense to you, then there's no way to...
Well, yeah, I think that's a consequence of what I said. It makes sense when you look at the implementation. It's where it doesn't work. And the name is very fancy, so it's a bit misleading. But
Thanks.
I've been wondering about the status of the SS reflect tactics versus the normal tactics, and what you're suggesting to use, or whether like for example, I sometimes encounter the case where like apply underscore or apply does not work, but apply with colon works, and or in different versions. So sometimes I just like try all possible combinations, like all possible versions of the tactic, or like the normal rewrite, SS reflect rewrite, and setoid rewrite. It seems like all can solve different things.
So I would describe the current state as like we integrated SS reflect in Coq a few years ago. So now you can easily use one or the other without any major cost. And, the SS reflect language is still evolving, and on one of the slides you saw some extensions on introduction patterns and things like that. What is still unsatisfactory is the redundancy between features of the standard tactics and the SS Reflect ones. So what I personally do is each time there is a redundancy, I use the SS Reflect variant for some reason. So the reasons might be different depending on the tactic. So like if you don't want to rely on the generating names, for example, for your hypothesis, then that's something that the SS Reflect tactics give you. The apply case is a bit specific, so there is a lot of work on that. They don't use the same unification algorithm, so that's why you see such key differences. The apply of Coq uses an old unification algorithm that other parts of Coq don't use anymore, almost. And but the apply column of SS Reflect uses the same unification algorithm as the top level type checker does. So there is work on porting some of the Coq standard tactics to this too, and try to reconcile all of this. But I'm not aware of any work about really taking those two tactic languages and unifying them, I don't know, by creating a third or something like that. I'm not aware of that.
As a follow-up on that, so there are two features that I mainly miss of the SS Reflect intro pattern language. One is in Coq you have like this intro pattern for nested conjunctions. That one does not exist up to my knowledge for SS Reflect. And also, I really would like to have a version of destruct with SS Reflect's introduction patterns. Because in the case of that one, is actually, it will generalize first. And
so I know some ongoing works on those 2 points.
Can you comment?
Like, so the destruction of pairs and tuples. I think Arthur Charliot has had a prototype where you can declare associativity and simulate what the Coq thing was doing with a bit less ad hoc infrastructure. And so the second point you said was? Sorry.
Destruct should
So
support.
yeah, destruct. So this Enrico has mentioned it to me recently. So having a variant of the case tactic that pulls out the dependency from the context before doing the...
And then introduces everything at the end.
Yes. So just wait a bit, maybe.
Still a question about apply and apply column. So you're saying that apply and maybe apply still using old unification. Is it going to change in the future?
So there has been...
Or it is a feature that will last for quite a long time?
So Mathieu has done a lot of work on porting the apply tactic to the new unification algorithm.
Okay.
I've tried to help him a lot, so that already a lot of energy was invested. We are at the point where we have same functional behavior. There are almost. But there are some performance concerns. So the old unification algorithm was doing locally unsound things, or even sometimes globally unsound things. And the only good thing about it is that you could forget about a lot of information and so be more efficient. So that may be a bit hard to reproduce. But so we are still working on it. This is the kind of work that is really hard to predict. So in the past, I remember, so we were reaching the last points where the behavior wasn't the same, and we thought it would be easy to fix, and then we had to spend like 6 months just to fix one small problem. So it's really hard to predict the amount of time that is remaining to get this done.
Thank you. Originally, SS Reflect is not part of Coq standard. Now it is. What about the MetaCoq? Do you expect it to be part of Coq standard in the future?
Well, we did not think about that really. We did not develop many tactics or anything else than the meta theory and this verified type checker yet. If it becomes useful to general users, it might become part of Coq. And of course, there is the idea that you might want to extract from the formalization of MetaCoq the kernel of Coq, so to bootstrap the system in a way. So that would be 2 possibilities for an integration in the future, but right now it's still going to be a separate project.
So just to add a quick thing, the idea of the Coq platform project by Michael Söcktrop is also to reduce the cost, like the difference between being integrated in Coq or coming with Coq. You know, it's like today you have to install external packages. They don't come with the same guarantees of having been tested with the same version of Coq and so on. So in practice, the user sometimes expect more trouble when something is not part of Coq. So this gap we plan to reduce. Right?
Thank you.
So following up this discussion on the packages, so I saw that there's some discussion about going over for Dune. What is the plan for Dune? Is it gonna take over OPAM eventually?
So no, OPAM is a package manager, right? Dune is a build system. So essentially they complement each other in the OCaml world. I mean, so the idea behind Dune was I mean, yeah, okay. The plan around Dune changes often, so I may be outdated. Okay, let me. The same movie. Anyway, but the idea is that it would rather replace Coq makefile and make rather than OPAM. Okay, for users.
Is there any way of getting universe indices to work with notations?
Yes, way, yes.
I tried and it didn't.
It doesn't work out of, it's not being integrated. So there is a separate syntax for notations. And we would have to allow binding universe variables there. There are different kind of variables and term variables. So you need also a different notion of substitution. But yeah. It's the first time I hear of this feature request, but yeah, it's quite possible to do, I think.
So just open a feature request, right?
Well, there is one case where you can use a notation and apply the notation to, if it's an abbreviation, you can give a universe instance. So if you have a notation for nil, you can apply it for example.
Can you repeat the question in the mic?
I was using an index that was bound in the section inside the notation for the sake of not having to rebind it later.
Okay.
Yeah. Okay, last question.
I would like to encourage that the meta theory of Coq gets a little bit of polish. As we know, it's currently not SN. There's been the exciting addition of SPROP, but we also know that there are a couple of questions left open there. And I think it would be really nice if we could clean that up a bit more.
Yeah, that's the goal.
Thanks.
Okay, so this was the end of this year's CoqPL. On behalf of my co-chair, Asja, and me, I would like to thank you very much for attending. We had a great show up, so that was amazing. I would like to thank all of the invited speakers, the Coq developers, and those that gave contributed talks. And I would like to thank the program committee for helping us accept abstracts and giving feedback to the authors. Also, last, I would like to thank INRIA for sponsoring the travel of one of our invited speakers. And I would like to thank SIGPlan for sponsoring the travel of another invited speaker.
Thank you, Robert. Thank you, Robert.
Okay, thank you, Robert and Asja, for the organizing the workshop. There will be another one next year, so we still have to organize it, but Asja is already volunteering for being on board. I don't have anything more to say.